Hey guys, welcome back to Monkmane Math. Today we're going to be taking a break from calculus and we're going to look at a cool problem. We're going to be doing some discrete math. Now, for those who don't know, discrete math deals with counting, basically. We're going to be doing counting techniques and we're going to be figuring out how can we add up big numbers and solve interesting problems. So I got this problem because some of my siblings are really into this game called Pokemon Infinite Fusions. And in this game, you can take Pokemon from old games and then splice them together to create new Pokemon. Now sometimes these new Pokemon look pretty cool and have really interesting abilities. And then other times these Pokemon are just disgusting. They're just complete abominations, and realistically speaking, they shouldn't exist in the game. But the thing that I'm curious about is, well, how many different Pokemon could you make? Well, let's go over the rules real quick. There are 470 Pokemon in this game. I think Pokemon can be fused with themselves along with any other Pokemon. And then the biggest thing is that each combination of Pokemon has two possible outcomes. And that's because a Pokemon can be fused with the head of one and the body of the other. So, for example, Pikachu and Charmander, if you put that together, you can create a Pokemon with Pikachu's body, Charmander's head, or Charmander's body and Pikachu's head, right? So both of those, and that's kind of the way that the Pokemon is determined. So let's go over how we're going to solve this. So before we try to solve this problem, let's look at some smaller scale groups of Pokemon, because trying to do this with 470 right off the bat might be a little tricky. So let's pretend for a second that there's only 4 Pokemon in this group. And how many Pokemon can we create out of these 4? Oh. Well, let's see. Let's do this, there's 2, 3, 4, 5, 6. So it looks like for 4 Pokemon, so I'll put P and C for the combinations. 4 Pokemon leaves us with 6 combinations. If we draw this again with 5, and it looks like we have 10, if we count that up. Okay, now we can keep going, but I just want to do these two so we can kind of see the pattern here. So I want you to pause the video real quick, and I want you to look at, we have 6 and 10. What do you notice about those two numbers? Take a second and think about it, and then we'll go back into it. So if we look at these numbers, it looks like 6 can actually be written out as 3 plus 2 plus 1. Okay, that's kind of cool. What about 10? Well, 10 can be written out as this guy plus 4, right? So 4 plus 3 plus 2 plus 1. And now we see a pattern here emerges. So we can predict if we were to do 6 different points, right? 6 vertices on this graph, we would have 15 lines. Because 5 plus 4 plus 3 plus 2 plus 1 is equal to 15. Okay, well, I have a little formula written on here for you guys. We don't have time to go over why this works. We can maybe in my next video we can prove why this works. But I just want you guys to see that if we add up, this is called an arithmetic series. So we add up numbers together to create some big sum. And that sum is going to be equivalent to this, n times n plus 1 over 2. If you're a little skeptical about that, let's plug in some numbers and check. Well, let's try with 4 plus 3 plus 2 plus 1, which we said was equal to 10, right? So let's see if that works. 4 times 4 plus 1 over 2 is equal to, let's see, 4 times, this is 5, 20 over 2 is 10. Okay, so it looks like it works. Let's try it again. Let's see if 5 works. 5, we said 5 plus 4 plus 3 plus 2 plus 1 is 15. 5 plus 1 over 2 is equal to, I believe that's 15. 5 times 6 over 2, 15, 30 over 2. Okay. Awesome. Now, the thing is, in our case, 4 corresponded with 6, if you remember, and 5 corresponded with 10. So we have to kind of go back one. So what we can do here is say, okay, well, we don't want to count up till n, right? Because we're not doing, for 4, we don't want to do 1 plus 2 plus 3 plus 4. We just want to do 1 plus 2 plus 3, because that gets us 6, right? So we only want to count up to n minus 1, right? And if we're plugging in n minus 1, we can actually plug in n minus 1 for this formula. So instead of n, it's going to be n minus 1 times, and here, remember how we had n plus 1? Well, now we have n minus 1 plus 1, which is just n. Right? So we're counting up to each number minus 1. So, for example, now, if assuming we set this up correctly, we should be able to plug in 4 and get 6. So let's test it out. So 4 minus 1 times 4 over 2. Let's see, 4 minus 1 is 3 times 4 is 12, divided by 2 is 6. Okay. Okay, awesome. Well, it looks like we got a little thing that works here. We have a little formula that we can use. So we have 470 minus 1 times 470 over 2. So real quick, I'll put this in my calculator. That gets us times 470. So 469 times 470 is 220,430. We're going to divide that by 2. Okay, so it looks like our answer is going to be 110,215. But the thing is, we did say before we started this that 2 things. Pokemon can be fused with themselves, and each combination of Pokemon has 2 outcomes. Because remember the body and head thing that we said? So we actually need to take this whole number. We need to multiply by 2, right? Which is actually going to end up canceling out this 2 on the bottom. Multiply by 2 for the head and body swap. And then we actually have to add 470 because of self-fusions. So when all said and done, it's going to look like this. 469 times 470 plus 470 right here. And if we plug all this in, this is going to be equal to 220,900 combinations. And it looks like that's going to be our answer. Okay, well, it looks like we found our answer. 220,900 different combinations. Now, if you look online, I think you get different answers depending on the game gets updated. I don't know, but this is what your answers are going to be, and this is the method of how you would solve that. So anyway, guys, I really appreciate you guys being here. I hope you had a lot of fun. Hope you learned a lot. Hope you feel like your math skills are getting better. If you guys want to go and try to complete that Pokedex, be my guest. I'm not going to do it. I'm sure someone will. I don't know. Maybe someone's that dedicated to Pokemon. Anyway, guys, I hope you enjoyed the video. Appreciate the support. Let me know what you would like to see in the next video, and we'll keep them coming. So yeah, have a great day, guys. Later.